Okay, new Kranzle. It's a product update, not a new pressure washer. But this is something that probably needed to exist a long time ago. I think we've kind of proven that something like this needs to exist by having the K1122TS. But this is a K1622TS with the actual total stop feature. The original model was called a K1622. This has total stop, so when I release the trigger, it turns off. So that's really the main difference. And so what I'm going to talk about here today, I'm going to show you how this works. I'm going to do some testing, give you a flow rating. I already know what the flow is because I've already tested the 1622, but we're going to show you what size nozzle makes sense, show you the stock gun and wand and the configuration, and show you kind of how to set something like this up. But we're going to talk quite a bit about the difference between a 1622 and a 1322 because they're the identical body, they look the same. It's actually also the same as the 1122. I may grab one of those and do a little comparison testing as well. But this is basically the same pump in all three configurations. You have the upright version in the 1122, which you can roll around on a cart. You have this sort of horizontal version that you can mount on a shelf or carry along with you with a handle, or you have the, of course, the 1322, which has a little more flow. It's configured differently. So the way that these pumps work, this is a radial axial pump. So inside of this area here, right in the center, their oil is here. But there are three plungers, and the plungers go in and out. And the way they go in and out, there's a plate, and the plate spins. There's a shaft that runs down the middle from the electric motor onto this wobble plate. And so as this turns, the plate will wobble back and forth. And so if you think about it, as this wobbles, it takes the three plungers and pushes them in and out, which then creates pressure, pressurizes the brass head of the pump here. There are three check valves in the front here, right here, 1, 2, 3. And so the basic idea here is that the pump creates pressure and pushes water out the outlet here. It comes with a gauge on the front. And the way that this wobble plate is configured on a 1622, it's configured for a happy medium. It's configured for a happy medium of pressure and flow. So this pump is rated at 1600 PSI and a flow rate of 1.7 gallons per minute. Now, I believe that flow rate is rated, I don't know how they test it or what the parameters are, but I believe they're testing it with some sort of machine right at the outlet, assuming no drivetrain loss, no loss to your hose and gun and all of that stuff. So what I've been doing over the years has been testing all these pressure washers using a comparative formula. I'm putting an MTM gauge on the end of my hose here, and I'm putting that gauge on the same spot and with the same sort of setup and the same gun, and then just adjusting the nozzles, which we'll talk about in a second here. And then I'm using the same bucket and the same stopwatch, so that way I can test the flow. How much flow and how much pressure am I getting in a real world sense? And then I have this big giant spreadsheet, which we'll refer to many times in this video. And that spreadsheet is a compilation of we're nearing 100 pressure washers at this point. I bought and tested more pressure washers than probably anybody on the planet. So to set this thing up, you need to plug it into the wall. So it comes with a 35-foot long, is it 35 or is it 50? I think it's a 35-foot long, really stout power cord. All these kinds of pressure washers, unless you're going to use a 10-gauge extension cord, you want to plug it directly into the wall, and it comes with a GFI connection or GFI power cord. And you'll notice a huge difference in the quality of the power cord on a Kranzle versus a lot of the cheap electric ones, even like the Karchers that I sell and some of the others. It's on a different level, different standard. And actually for the US market, Dirt Killer USA is the US importer, Kranzle USA. They actually buy these power cords, ship them to Germany, and then Germany configures the capacitor in here to make it UL approved and set up for the US power grid. And so they get a really awesome power cord that comes with these things. So you plug it into the wall, you press the button, make sure you turn off the machine. You don't want to run it dry if you can help it. And so if I went to turn it on, it'll fire up the pump. You won't damage anything, but you don't want to run it without water if you can help. So make sure to turn it off, or you could hit the GFI connection. One of the biggest differences or biggest advantages of the 1622 versus the 1322 is power consumption. They're both rated to run on a 15 amp circuit, but when you start using things like a foam cannon and you start using different size nozzles, you're going to run up against the capability of a 15 amp circuit. So this 1322 in the configuration I have it set up here, I'm going to use a 4.0 size nozzle. Will run fine on a 15 amp circuit, but as soon as I plug in my foam cannon and drive the machine a lot harder, it's going to draw 16, 17 amps, and you'll end up kicking the breaker, or you'll kick the protection circuit on the Kranzle. More often than not, the Kranzle protects itself before it kicks your breaker. So on 1322s, I recommend you have, I don't have a clean dedicated 20 amp, but I at least have a 20 amp circuit that I don't have a lot of stuff connected to. So you need a 20 amp. What you can't have is your Kranzle, your 1322 plugged in and have a, have a TV running and a fan and all of that stuff on the same circuit. It's just not going to work. Whereas this one, this pressure washer, the way it's configured, draws quite a bit less current, even with the foam cannon. Where this is going to draw 17 or 18, this with the foam cannon is going to draw around 1300. So I'm calling this my 15 amp machine and that my 20 amp machine. The disadvantage though is I'm going to get a lot less flow. We're going to get around a gallon and a half a minute, where this one's going to create about 2 gallons per minute. So the way that this is configured is a happy medium of pressure and flow. That is pretty much configured for flow, which I prefer for washing a car. So in a perfect world where I have at least a 20 amp circuit, I'm going to choose the 1322. But in an imperfect world, especially if you're a mobile detail, you're traveling around, this might make more sense if you don't have as much power output or power capability. And we're going to test that here in a minute. I've already run it on the 1622, so I'll be able to compare. But we're going to test the output of what this does with a foam cannon on it. So configuration, the way you're going to want to set this up, this is a Mosmatic full T304 stainless M22 14 millimeter to 3/8 plug. So even though this outlet is brass, I prefer to have all of my fittings be stainless. We don't need stainless. Stainless is really for 5,000 PSI applications. This is going to be 1,000 PSI-ish. And so we don't need this type of fitting, but I much prefer it. It looks cleaner, nicer, neater, won't corrode over time. And even though the head of the pump is brass, having this type of connection, this type of fitting makes a lot of sense to me. So you're going to put one of these on the outlet. Then the other difference between a 1622, this retails for 990 bucks today. The 1322 retails for 950. So one of the reasons is these are lower produced, lower volume. I have exclusivity on this. They don't make this pump anywhere else. And so this pump costs more to manufacture because they have to change the production line, order a special wobble plate and all of that. But this, because almost always, every single time I'm selling this in a configuration that's either custom or a configuration with my own hose and gun recommendations, this doesn't come with any accessories. It just comes pump only. The 1622 is a lot more prevalent and available for everyone in the US. And so this comes complete with a hose, a 35-foot hose, and a rather extensive gun. Which actually is not a bad thing to have if you want to clean patios and things like that. But it does come with this fanned nozzle. This has a 2.8 size orifice on it, and it's a pretty significantly sized and heavy duty gun, but not so great for washing cars. So I think you're still going to want to upgrade that. But if you wanted to take your time, for an extra 40 bucks, you're getting a really nice hose and a gun and wand. My preference, again, would be for the 1322 and get my own gun and wand, but that's going to add, $300, $400, $500 to the ticket. So this is something that I've had created. It did not exist. We should have cheaper versions of this soon, but this is a true T304 stainless, highly precisely made M22 fitting, M22 to 3/8 coupler. Believe it or not, this didn't exist. It only existed in brass. And so now this sucker here is like 50 bucks. If I'm buying a $900 pressure washer, I'm going to spend a couple $100 on my fittings. You have the choice. We have these in brass for $5 or $6 or $7. We have them in stainless, cheaper stainless, Chinese-made stainless for $12 or $15. And then we have it in this T304 stainless connection that only I sell that you could use as well. So if you do have a 1622, if you have the new 1622TS, or if you have the 1122TST, if you have any of the Kranzle branded hoses, this is the fitting you want. So for all of you guys who have bought a K1122 from me over the years, if you're watching this video, go to the store. We'll have it in the cards and in the description. Make sure you want to buy one of these to replace. I had for years sold an adapter fitting. It was a twist and seal plug that converted. Well, now we have these available. These are specifically made for a Kranzle hose where they're the exact right length. I had to make 5 or 6 different iterations to get this thing right. So in this application, I like to have couplers on both ends of my hose and have plugs on the outlet of your pressure washer and inlet to your gun. And so this is the way I always configure hoses. It's just nobody makes, and the quality wouldn't be as good. Nobody makes a female stainless coupler that converts M22 to a 3/8 plug, or a 3/8 coupler, I should say. So to go female to plug and then to our coupler here makes more sense to me. So look at how clean that connection is. So again, this comes with a Kranzle hose, not as nice and pliable as a Cobra Jet hose, but still certainly will get the job done. So what I'm going to do for this test, I'm going to put an inline pressure gauge, and you can see the difference between a Cobra Jet hose. So this is a 1/4 inch Kranzle hose versus a 3/8 inch. I found no pressure difference, no output difference between a 3/8 hose and a 1/4 inch hose. I've found that these will tend to break and tend to leak much more quickly than a Cobra Jet hose. But if you're just starting out and you're going to spend $1,000, it's nice that it does come with the hose. So I know a lot of people will probably like that. Again, my preference is keep that fluff out of the package, and we do not have the option to buy a 1622 without the hose. It comes with it regardless, so you're going to have it. So I'm going to take my pressure gauge, put it in line. I also put one of these couplers, or plugs, I should say, on the inlet to the gun, so I can get this quickly connected or disconnected. So I want to test the output of this with the stock setup, and it reads 2.8. So that means what we're likely going to get is less flow and more pressure with the way that this gun is set up. We're probably going to tune that a bit by likely end up putting a bigger nozzle to dial the pressure back and try to increase flow as much as possible. So then the other thing we need for this is we need to get inlet to it somehow, and I prefer to do this in a quick disconnected fashion. Notice I haven't used any tape. All of these are rubber O-ring type fittings, and then you also have a rubber O-ring on here. I will generally still tape my garden hose fittings, but just for the simplicity of this video, I'm not going to do that. This is a 12-foot inlet hose. Oops, I just sprayed all over myself. So this is a 12-foot hose that we're going to put in place. All right, before we fire this up, let's talk a little bit about nozzles and talk a little bit about orifice size. So if you haven't watched my series on pressure washers, when I started doing this, I really didn't have a clue how any of this worked. There are charts that you can utilize, and we have them on the site, but MTM provides it as well, or you can just Google search GPM chart or pressure to flow chart, but there are charts that kind of give you a rough idea, the linearity of what happens, or the change that happens when you change the size of the hole. There's a hole in here, so when you change the size of the nozzle, the orifice, the size of this dictates how much water can pass. And so if you think about this logically, if I open up the hole, I have more flow, but I have less pressure. So a 2.0 nozzle should create more pressure than a 3.0 nozzle, or a 4.0, or a 5.0. And so this machine is designed to run on a 2.8 size nozzle. That's what they designed it to do. I can adjust it a little bit within reason. What you can't do is just say, I want 3,000 PSI out of this, so I'm going to put a 0.1 or a 0.2. They don't even make them that small, but I'm going to put a 1.0 nozzle because I want to get tons of pressure. The problem is if you do that, then you'll end up possibly drawing too much current, kicking the breaker, blowing up the motor of the pump. So even though you have this chart, and in a perfect world you have this exchange between flow and pressure, in the real world you have limitations, right? And so if this comes recommended at a 2.8 nozzle, I have some room to maybe go up to 4.0, maybe down to 2.0, and 2.0 is probably pushing your luck on it. And you won't know until you just blow up the machine. You're just driving it too much. And it won't blow up right away. Kranzles are pretty good about it. If you put the wrong size nozzle, wrong size orifice, wrong size foam cannon on it, you might, it'll just go into protection. So just keep that in mind when you're talking orifice. So on this machine, when I tested it in the past, in order to get around 1,000 PSI and get the most output flow-wise, I had run it with a 3.5 nozzle. So you can see I'm running, instead of 2.8, I'm running a 3.5. So that should be acceptable. So let's fire it up here and see what we get out of it. So on a Kranzle, I'm going to have a whole, I have a whole maintenance series where I traveled to Kranzle USA and we tore apart a machine and showed you how to rebuild it. I'm going to be doing that. I actually have a 1322 over there that has a problem. I have my old 1622 which has never been serviced, so I'm going to have a service video. But always check the side when you get it out of the box. Just make sure you can see some oil. There's a little oil gauge on the side, or a little transparent oil area on the side here. Other than that, don't mess with the red knob. You don't need to start adjusting and playing with the unloader. The unloader should be turned clockwise all the way. When you unload, you can adjust the pressure, but really you're just diverting pressure and causing heat buildup. You really want to run the unloader open. It's not a great place to adjust pressure. It's generally preferred you adjust pressure at the nozzle by changing the size. You can adjust pressure with this. You would unload it if you wanted to do some soap injection or something. But with us in washing cars, soap injection doesn't work very well because you have to run it at like 500 PSI or less. So we're not going to mess with that. All right, so we're set up. We have our inlet, we have our outlet, everything's connected, so we should be good to turn it on. Let's hope we don't spring a leak anywhere. See what happens. Hope we don't drench our sauna cabinet. Okay, so now we're on. And so again, you want an inlet hose. I think you want quick disconnects, and I think you want all this quick disconnected, but now we're locked on. You won't be able to pop this loose. Let's fire up our machine. So in the past, a K1622, which sold for 890 bucks, so it's 100 bucks more at 990. If I turned this on, it would just run. Very quiet, very subtle, very clean, could run for a couple hours at a time. You generally wouldn't want to just let it sit there idling, but you could run it, these are designed for commercial applications. But now what's going to happen when I turn this on, because there's no water flowing through, it's going to build pressure, and then this is going to kick and turn it off. Kicked off. And so and a lot of times it'll make a funky noise when you first turn it on like that. But now theoretically the machine's under pressure. If you find that you get surging or it kind of cycles on and off, that means you didn't do a good job of setting up. One of your fittings is leaking, maybe your hose bib is dripping. That's the only thing that will really cause this to surge, where it goes on, off, on, off. But right now it shouldn't turn on because I've got a good clean chain. It shouldn't turn on no matter what. My gauge reads 0. By the way, this is a glycerin gauge. Glycerin is a type of oil-like substance, has a thicker viscosity than water. There is an air bubble that is by design, so don't freak out when you get your pressure washed and you think it's broken. I always have to remind people of that. Read the descriptions on the website. All right, so let's see what kind of pressure we're getting out of the stock setup. So clearly this is designed for, I'm going to be cleaning my deck or doing some sort of washing of the house. It's just too much to be using for washing a car. I do like having this because a lot of people want to do dual use. They want to use their pressure washer to clean around the house and things like that. We've actually just gotten our prototypes done. I will be having some Mosmatic wands that are longer for our Mosmatic gun setup in the future. But for washing a car, which do you want? Do you want this? Or do you want this monster? In the beginning, I used to use a garden hose to clean my wheels because how the heck are you going to clean your wheels with this sucker and try to get in and clean the surface? All right, so let's run the air out of the line. This is a fan, so I can adjust the output. By the way, this probably won't affect pressure. Let's see what happens if I adjust the fan output. So I'm getting 1450 PSI. And if I change it to fanned out, I'm getting 1450 PSI. That's another common misconception, is that, yes, technically I'm probably getting more pounds per square inch if I'm using this like so on that spot. But theoretically, the amount of pressure that's running from the machine is the same. And so if you change to a 0 degree or a 15 degree nozzle, or you change the fan output, you're not going to see a different reading on the gauge. One other common trait of a higher end pressure washer is there's no pressure drop. And so my gauge is still under pressure even when the machine is off. And so when I release, notice how quickly it builds pressure again. Whereas like a cheaper, like a SunJoe or an AR Blue or something, some cheaper pressure washer, this gauge will drop down nearly to 0, and there's a ramp up. And so this is generally a sign generally of a better pump. And so when I'm running this, so I have the gauge on the outlet of the pressure washer. So this reads about the same, about 1400 PSI. So again, my unloader is all the way in. So I'm getting max pressure. So now the question, this is rated at 1.7 gallons per minute. I'm going to start my stopwatch, and we're going to see how much flow we get from this machine. My amperage draw, I'm going to plug it in. I have to plug it in here. So don't plug this in like we're doing it, but we're going to do it anyway. We have an extension cord and another thing. So let's see how much current we draw right out of the box here. It should be on V. You got to hit the GFI. V. Okay, so they have this tuned with the factory setup. This is drawing like 14.8 amps. We're actually going to draw less current when we open up the size of this a bit. So this is truly a machine that's designed to run on a clean 15 amp. You probably want a dedicated 15 amp circuit. And so we're gonna set up a foam cannon to make sure we can still run this. But with a 1.25 millimeter orifice, I think I drew like 11 amps or something like that. All right, so let's test our flow. Again, we were getting, what did I say we were getting, 1450 PSI? 1450. So let's see how much flow we get. Three, two, one, go. So the K1322 gets us 1.97 gallons per minute. So 2 gallons a minute is what I real world tested. So theoretically, this is going to give us around 1.5. It's rated at 1.7, but let's see what we get out of it. I don't think they've done any configuration to the 1622s. They just put a pressure switch on it, but we'll see. "45 seconds. Boom. 1 minute. I'm rooting for this guy. Seems like a lot of water. I just did a SunJoe, so that's probably why it feels like a lot of water. 15 pounds, 3 ounces. We're going to subtract 2.2 pounds, 12 ounces for the bucket and divide by 8.34 pounds per gallon.
Double check the rice paired the scale.
Too late.
Okay.
Yeah, 15 pounds, 3 ounces. Yeah, so 1.55 GPM. You know, so that's what we're getting with our 2.8 nozzle on the stock gun. So 1.55 GPM at 1450 PSI. So now we're going to change that a bit for washing cars. So on a house, the way that this is set up, this is maximized to get you the best cleaning units, to get the best cleaning capability. Take GPM, multiply it by pressure, and you get cleaning units. So Kranzle's tuned this machine to run it right at 15 amps to be able to do as much cleaning as humanly possible in the stock setup. So now we're going to modify that a little bit to try to make it better for washing a car. Okay, so let's swap over and let's start playing with our orifice size here. And let's maximize, you know, I want a little less pressure for washing a car. Now, you could be fine if you put a 2.5 nozzle on this sucker. So why don't I just do that real quick for you. So if I put a 2.5 on this, I'm going to get somewhere around the same pressure, a little bit more. The gauge is a little leaky there. So if I take a 2.5, 40 degree, this should give me around 1500 PSI. Just run our air out. Yep. We're still within the range, so to change from 2.8 to 2.5, not a huge difference. But I'm getting... Now this 2.5 is giving me 1400 PSI. Let's see what a 2.0 does for me. Let's make sure I got that right. Yeah, it's a 2.5. So this is a 2.0. Yeah, that 2.0 is giving me... So you don't want to do that. It's drawing 17.2 amps. So I'm overamping the machine, and it's giving me 1700 PSI. That's 1675 PSI, but I'm drawing 17.2 amps with that 2.0 nozzle. I don't think this 2.5 doesn't seem right. Let me try one of these other ones in here. You know, these are Chinese-made nozzles, so they're not extremely accurate. Yeah, 4.0. So I suspect this is rated at 2.8, but the actual nozzle output is probably closer to 2.2, 2.3, something like that. You know, it reads at 2.8. So when I'm running a 2.5, I'm actually getting 50 PSI less. But remember, when I put that 2.0 nozzle, I shrunk the hole. So if I do that, I'm going to shrink my output, my flow. And remember, for washing a car, I don't want so much pressure that's gonna, I'm not sticking my hand in front of 1700 PSI, I'm not doing that. But if I did, it would hurt. I want it to be around 1,000. So let's try a 3.0 nozzle on here. I think I'm gonna have to go grab probably gonna have to go grab a 3.5. But in all my testing of the 1622, I prefer a 3.5 nozzle. Yeah, see, that's a 3.0 at 1200. And it's just, you could roll with that, but you know, we're still gonna be getting around 1.5 gallons per minute. So I wanna ramp up the GPM on this if I can by opening up the nozzle a little bit. Now on Kranzles, I found that it's not, when I said proportional in the past, it's not directly proportional. So on some of the cheaper pressure washers, you find that if you open up the nozzle a half size, it really changes the pressure and it really changes the flow. And anytime the pressure changes on like a SunJoe or something, you get quite a bit more flow output. I don't suspect we're probably going to approach like a 1.6 gallons per minute by opening up the nozzle by, you know, almost a full size. So Chris is going to go grab that, and while he's doing that, another thing to consider, it's just not as easy for me to swap these out, but if you do the OG spec setup, this is the way to go, where I've got protection that if I hit the fender of my car, my nozzle's embedded. Yeah, this is a 4.0 40-degree nozzle. Now these are a truer 40-degree pattern than the, whatever you call it, these MTM ones. So some people might prefer on these Mosmatics, you might prefer a 25-degree. We sell them in 25-degree as well. Do we not have a 3.5?
No, we don't have a pack of them over there.
Well, let me just make a, I'll go make a Kranzle or a OG spec Mosmatic. All right, so a 3.5 size nozzle gives me exactly dead on 1,000 PSI. And I think a lot of you, I would highly suggest, just depending on the output of the pressure washer, I'd highly suggest you get 40s and 25-degree nozzles. You might like the 25-degree better. So 25 degrees on these OG specs, I found like on my big, heavy 3-gallon per minute Kranzle, the one I have at my house, it's just much better having a 40-degree. But on some of these are lower flowing machines. Not ultra low flow like the cheap ones, but these are much lower flowing than like a big 20-millimeter pump like what I have at my house. So I'd actually probably want a little bit more. I'd want a little bit more. I want 1,000 PSI, but I probably want to do a 25-degree nozzle. But the flow won't change. All right, so let's test our output now. So we got our 1,000 PSI we're targeting. Let me check our current draw. So we probably dropped current, which will make it a little safer. Yeah, see, now we're down to 11 amps. So we got 11 amp draw instead of 15 or 14.9. So that'll make it safer for us to use on a regular circuit in our house. Because again, the major advantage of this for me is that I'm going to be able to use this on a regular circuit in my house, or a regular, you'll still need a hefty generator, but a regular version. Just makes it a little bit more realistic. Okay, let's go stopwatch. Why are they yelling at each other in there? Ready? 3, 2, 1, go. Gosh, it sounds so smooth, this thing. It's operating at 65 decibels. It's about 3 dB quieter than the 1322 is, with a bigger wobble, with a bigger throw. The 1322 at roughly 15 feet will do 68 decibels. It's such an enjoyable sound, very quiet. Okay, so now we theoretically should be around 1.6 gallons per minute. So that's, yeah, 15 pounds, 12 ounces. See, Kranzles don't pick up a lot of flow with the reduction in pressure. 15 pounds, 12 ounces. Yeah, 1.61 GPM versus that same setup. I would run a 4.0 nozzle on the 1322. It's going to get me 1.97, so 3/10 more, almost 4/10 more GPM from the 1322. So at the same pressure at around 1,000 PSI. And so the way this is configured, the wobble plate on this is configured really to benefit most for pressure, to get a little bit more pressure output, because the 1322 is going to get 1,000 PSI. They're going to recommend a much bigger, like if you try to run a 2.8 nozzle on your 1322, it's not going to go well. So again, 1622 is configured a little bit more for pressure than it is flow. But 1.6 GPM is still great. But again, my preference is going to be for the more stout machine, the machine that's, let me rephrase it, the machine that's drawing more current, the little bit heavier draw and a little bit better output. So on this machine, I've already tested this in the past. Do I have a spec on the foam cannon?
1622?
Yeah. A 1.25 millimeter orifice on the foam cannon draws how much current? 11.4. Yeah, 11.4 amps. And so if you run this the way that I recommend, where we do a 1.25 millimeter on our foam cannon, that's the size of the hole inside of our foam cannon, right here. So the standard 1.25 millimeter orifice, you run a 3.5 millimeter on your Mossmatic gun. And again, on this, I would probably run a 3.5 millimeter 25 degree spray pattern if you're going to do the OG spec, or 40 degree spray pattern if you're going to do the 3.5 MTM if you're going to buy one of the nozzle packs. I mean, this is a $40 thing. These are a $14 pack of 4. So these are 40 or 50 bucks, much more expensive. So not everybody's going to buy that. But if your chances are, if you're buying a Kranzle, you're buying one of these. So again, just to recap, K1122TS, total stop. No gun, no wand, no accessories, comes stock. This one does 1.97 gallons per minute at 1,000 PSI. K1622, $40 more, so that was 950 bucks. This is 990 bucks. That's price shipped, to your door. So this one comes with a hose, not an inlet hose, but an outlet hose. No quick disconnects, but it comes with an outlet hose and a gun. The big long gun, the big long Mossmatic. You can't opt out of that. It comes with that regardless. But this is going to do 1.6 gallons per minute at 1,000 PSI. So roughly 4/10 of a gallon per minute different. So the output of that is greater, but it's also, this is going to draw around, what was my current draw on a 1322? No, with a, just with the Mossmatic. Yeah, so this drew, what, 10.8 amps, whereas this drew 13.5 amps. That with a 4.0 nozzle on it as well. So a 4.0 nozzle got me almost 3 amps more. So you really need a dedicated circuit. This one, this is for the homeowner that you just don't have a choice. You got old wiring, or you got a house where you have outlets. It's just not practical to upgrade. You're gonna have a really hard time running at the K1322 the way that we configure it for washing cars with a foam can and everything, you're going to have a hard time on a circuit that isn't at least 20 amp, and in a perfect world, a clean, dedicated 20 amp. This machine you can run on a used 15 amp circuit. You might not be able to run a bunch of lights at the same time, but the 1622s, for those of you who have problematic wiring or not a lot of capability, and you're going to give up some flow for that. We could reconfigure and just do bigger nozzles. We could do a 1.5 nozzle in our foam cannon, but you're going to end up in the same spot. So again, I think the place to go would be to do the 1622. Again, if we don't have the capability to get the proper amount of power output. So that's really all I can think of this. We do have the Krenz gear oil in the store. I'm going to be, like I said, I'm going to be doing some more videos coming up here, talking about changing out gauges. One of the beauties of all of these Krenz machines is that they're completely rebuildable. I can basically take the whole thing apart. Everything outside of the electric motor, if something happens to the electric motor, you're not in good shape. You might as well buy a new one. But their electric motors are super stout, super high quality. The capacitors they use are a big giant, big giant brick inside of the thing. The circuits, the electronics, the switches are changeable. The check valves, all of the unloaders, all these parts and pieces are very easily replaceable and changeable, upgradable. If you ever have an issue with your total stop device, your pressure switch, that's changeable. Hoses, or the Kranzle hose is very expensive. These are like $200 if you buy it retail separately. So you are getting a high quality hose and gun. It just depends on if you need that around the house or not. It's a good thing to keep. I've always found myself throwing it away and not ever using it. I'm always going to upgrade my hose to a Cobra Jet or something like that. All right, so let's talk a little bit about cleaning units here and how this helps us compare pressure washers. So cleaning units is a function of how much current draw, right? Especially when you have equal or very similar pumps. So the 1322 again drew 13 and change amps at 1,010. So it provided 1,010 psi at 1.97, 1.98 gallons per minute. So that would give us around just shy of 2,000, 1,990 cleaning units. 1,980 cleaning units is what we get on a 1322. A 1622 is going to draw around 11 amps, with our setup, with our modified setup. So, 2 and change less amps, less current draw, but it's going to get us 1.61 gallons per minute at 1,000 psi, or roughly 1,600 cleaning units. So if you are using those to correlate or directly compare how much work I'm getting done, how much better my cleaning capability is, I'm getting roughly, roughly 15% better cleaning capability by having more flow, but I've got to have the power in order to be able to deliver that. And so that's why I think this machine still holds a lot of value in applications where I don't have as much output current-wise, or I don't want to be up against it, because the foam can is going to be the real test. This drew 11 and change amps versus 17 or what was it, 13 amps versus 17 amps. So you're blowing through any 15 amp circuit on a K1322. So I thought I'd mention that, just sort of keep that in mind as you're comparing, as you're thinking through this stuff. Specs aren't everything, but it does make sense when you're going like for like, pressure washer versus pressure washer. So that's the 1622. Make sure to go to, if you go to obsessgarage.com or just check the link in the description, I have all of this product testing. We've created a spreadsheet with all the data on all of this stuff, all of my recommended pressure washers. I'm going to call this one, I guess it would be number 1A, in that I like this, but only if you have to have this. Otherwise, you're almost always going to want the 1322. I'm not just saying that because I have exclusivity on it. I'm saying that because it has a different wobble, it has a different configuration. It's really perfect for washing a car and getting the most out of what we can get out of a pressure washer like that for, for less than $1,000 bucks. If you have an infinite budget, then we want to do something different. We want to run a dedicated 30 amp circuit, and we want to do something like the K165. Actually, it's the KWS 700 would give us around 4 gallons a minute, but you need 30 amps to get that. That's what I have in my wash bay at home. But here in my garage, I mean, the pressure washer I use all the time is the K1322. But it's nice to have options. I'm glad that they're taking the 1622. My guess is this is a request of all the other people selling Krenz pressure washers, that why can't, this was my argument in the beginning, why can't we make the 1122, which has total stop, where you release a trigger, it turns off, why can't they make the 1622 do that as well? So it makes perfect sense to me to have this option. So available in the store, obsessgarage.com. Thanks for your support. I love these darn things. This is like the Porsche of pressure washers. Not the most horsepower, not the prettiest looking thing, but the engineering and the quality is there. Remember that these suckers weigh 50 pounds, and it's generally pretty hard to get it to you intact. But if UPS can get it to you intact, they box the heck out of these things. This thing will last you a darn lifetime, and it's great that it's rebuildable. And I'm going to teach you how to maintain and serve these things yourself. I think pretty much anybody who can use a wrench can service these suckers themselves. So thanks for watching. Thanks for your support. As always, stay tuned for more crazy. I'll keep keeping you up to date on these kind of things. Catch you soon. All right, little bonus footage for you here. I realized I didn't have a original gun and wand for the K1122, so I haven't compiled the specification for the rated 4.2. So you can see the pump configuration is different on an 1122 than it is on the 1622 TS we just tested. This I've rated or gotten 1.9 even gallons per minute. I think it was maybe 1.89 gallons per minute out of this K1122. Now remember, this pump is the same pump, just with a little bit slightly different internal configuration. This one comes with a hose built in, and so for those of you who have, or watching this video, who have a K1122 and have my original setup, you're going to want to buy one of these new Mosmatic fittings. Cost you 50 bucks, but man, is it smooth. And so this will get rid of some of the bulk from the gun, whereas I've got an adapter there. And so I want to test the output of this machine with the stock setup. So this is the same exact gun as the K1622, but the wand is different. The wand has a classified 4.2 nozzle. So we run this with a 4.0 nozzle on it. But again, this is not particularly 15 amp, certainly not 15 amp circuit friendly. That's where the output, the restricted output of the K1622 makes sense. Otherwise, you're always going to want this or the even better configured, because we get another 1/10 of a GPM output of the K1322. But I do want to get the specs for this, because we didn't have it. Just do a quick little disconnect here. This is a brand new machine. I had opened it so that we could take photos of it. I should probably sell these. Get them out of the warehouse here. I've been holding on to it for demonstration purposes. Okay, we're in. Get this out of the way. Let me put my gauge in first. I'm going to feel good about my spreadsheet now. Turn the water on. Hope nothing explodes. So I turn my machine on, so I shouldn't have any leaks. Builds pressure, turns off. Oops, I'm gonna go this way with it. For oiling, This has to be on its back. Something isn't right here. So we are 1050 psi at what? 16.4 amps. Yeah. So you can see, even in the stock configuration on a 15 amp circuit, you're gonna have a tough go. But this just feels more stout than the 1622. All right, let's get our GPM reading here. Again, I've already tested this with a 4.0 nozzle with the Mosmatic. Gets us 1.9 gallons per minute, but I wondered what it did in the stock configuration. 3, 2, 1. "15 seconds. The 1122 also comes with a dirt killer nozzle, which has a little thing that spins, so it gives you more perceived pressure. That's why this is such a good machine for cleaning around the house. I used to tell everybody, you don't want this for cleaning around the house. It does a decent job. Just know that you're right at the limit of a 15 amp circuit, even with the stock gun. Okay. Oh, the scale is going to work very much longer than this. That feels like a lot of water. 19 pounds, 2 ounces. Now you're also going to see a little variation from machine to machine. So if you run the same test, your gauge may be a little different. The machines are, German engineered, but they're not identical. 2.02. Ooh, 2.02. So that I want to test this with the other gun and get fresh specs. So 2.02 gallons per minute. So you can see where they're getting that spec from. So this, actually that makes sense. I don't need to rerun it. So because this is a 4.2 nozzle, it's a little bit bigger than the 4.0 nozzle that we run on it. So the 4.0 nozzle, see, that's why I don't think the specs on these nozzles is accurate, is correct. So what was the
4.0 nozzle took me down to 950 PSI.
Yeah, so let's retest this machine since I did all my tests on my old machine, so let's do it on the new machine with a 4.0 nozzle. Another way, this is how I run my machine dry. Just let it run for a few seconds and kill it. So that way I can pull off my gauge. Let's do this, that. I want to test this new fresh machine. 4.0 nozzle, water on. Wow, this one is quite a bit more output than mine did, because I'm getting, what's our current draw?
16.8.
16.8 amps. And I'm getting 1090 out of this with the 4.0. Yeah, I mean, my machine is 10 years old, and so I was getting 900 and change out of the 4.0 nozzle. I was getting 900 and change at 1.9. Now we're getting 2 gallons a minute at 1,000 and change. So let's see how much water flow we got now. So we should have a little less flow than we did with the stock gun. So we could consider running a 4.5 on this, but I like where the pressure's sitting at 1090. That's pretty good. Interesting, very interesting. This makes me fall back in love with the old 1122. Sounds so good. Just sounds like a German high quality machine. Parked at 1090. 20 seconds. So this is like a car. You put a car on a dyno, and some cars just dyno better than others, you know, even though it's made in the same factory. This little guy has more output. Three, two, one, pull. So we have a little bit more pressure, so technically this should be a little bit less flow. £18, 9 ounces. Yep. 1.95?
Yes.
So that's right on. 1.97 was our K1322. Yeah. Anyway, thanks for watching. Catch you on the next one. Make sure to check out the spreadsheet.